Welcome guys to my first video that I'm ever making on programming. I've been doing this for the past year and a half or so. So today we're gonna learn how to install Cuda toolkit on your Linux distro that you have installed inside your WSL. So first of all, you need to know whether your operating system is compatible with WSL or not. You need to have a Windows 10 and or higher, like Windows 10, 11. These two version of Windows support WSL2, and it is preferred that you install WSL2 because WSL1 has some compatibility issues with a lot of software. So to check for WSL2, to start WSL, you need to open up your terminal. In this case, I'm running PowerShell, and then you need to type in this command WSL install, which will start installing WSL. But as I have already installed WSL in my system, this just started launching Ubuntu, which is the default distribution of WSL. When you put in this command, it's going to install Ubuntu. Okay, let's shut this down and then figure out how to install Cuda toolkit. So to install Cuda toolkit, you need to find out the version of Nvidia drivers that you have installed in your system. To do that, you will again open up your terminal and put in this Nvidia SMI command, which will show you your GPU's detail. It will show you which version of drivers you currently have installed in your system, and the Cuda toolkit version it has support up to. So you don't exactly need to install 12.6. If you want, you can, but most machine learning or most AI libraries such as TensorFlow or Pytorch, they usually have builds for Cuda 12.2, 12.4, I think is supported by Pytorch now, but Cuda 12.6 is yet not supported by Pytorch. So if anyone is seeing this video in like 2 or 3 years, maybe you have something like Cuda 12.8 or 13.1 or something like that. So always check the website of Pytorch or TensorFlow and then verify up to which version of Cuda they support and then install that version. Okay, so now that I know that 12.6 is supported by my GPU and drivers, I will look for this Nvidia Cuda 12.2, which I usually download. Then we can go to the Cuda toolkit downloads. We can also look at the homepage of Cuda toolkit, and we can see that the Cuda toolkit 12.6 version is available by default. So if you directly go to the website of Cuda toolkit, you will see that Cuda 12.6.0 and driver version 560.76 is there by default, and we will not select Windows. We are going to go for Linux, but let's come to the 12.2 version, and then we're going to go to Linux x86, and we are installing it in Ubuntu and 22.04. Now let me first install a version of Ubuntu that we are gonna let me get a fresh version of Ubuntu 24.04 LTS. But you can find a lot of other distros in Microsoft Store that will, if you install from here, it will directly integrate into your terminal and into the WSL. So you can use this command like WSL list. Okay, wait. What? Shit. Yeah, right. We can list down the amount of distros that we have and install version. List, yeah, right, with 2 hyphens. So I have Ubuntu, which is my default distro. I have an Arch setup and a Docker desktop. Docker desktop requires WSL to run, and let's ignore Docker desktop for now. But after we are done installing Ubuntu 24.04 LTS, it will show up here. But let's let that install and then we'll figure out. So in WSL, we're not going to select Ubuntu. Ubuntu and Ubuntu are different. Ubuntu is a whole operating system running separately in your computer. You can dual boot it. I have Ubuntu dual booted on my system, and maybe in the future I'll also make videos on Ubuntu. And I usually work on my development stuff on Ubuntu. But as I'm in Windows right now for WSL, I'm going to click this version 2. Cuda is only supported on WSL version 2. So if you have WSL version 1, you need to upgrade it. You can install the .dev files on WSL, but this will cause some problems because Cuda's .dev files comes with the drivers. If you see here, you can see the Cuda 12.2 supports, if I'm not wrong, Nvidia drivers 535.86 or 545. So this is not gonna work with our drivers, which are 560.81. So we need to install a Cuda that does not have drivers built into it, Nvidia drivers built into it. So for that, we need to install the run file. And to install this run file, yeah, see, Cuda 12.2 has 535.54 drivers built into it on the .dev files. So we have to install this. Now to install this, first we need to go to our distro, which should be installed by now. Yeah, it is installed by now. Now we're gonna open our terminal, and then here it is, Ubuntu 24.04. If you open it, you need to set it back up. Installing this will take a few seconds. Let this install, and here's the PowerShell. So we need to give it a username. Let's give it, say, entropy, and then we need to, okay, Unix doesn't allow capitalization in the username, and we need to give the password. Let's give it a password. Okay, right again. Yes, sorry, it's done. So let's clear our terminal. So let's run sudo apt update. Sudo means super user 2. It is basically running the command as admin. Sudo apt update. It is gonna update all the packages that needs to be upgraded. Update means it's gonna look for packages that needs an upgrade and list them out. We can see it's going through a lot, and then yeah, it found 142 packages that needs to be upgraded. So let's see how the packages that need to get an update. So as you can see, Python, OpenSSH, many built-in libraries of Ubuntu, and fdisk, which is an disk management utility, etc, etc, vim, uget, wget. We're gonna get around wget. We're gonna install Axel, which is a multi-threaded application for downloads in the terminal. I'll show you how to do that in a minute. So let's upgrade the packages. Sudo apt is the package manager used by Debian based distributions like Ubuntu, Pop OS, and Solid OS, if I'm not wrong. Sudo apt upgrade, and it is upgrading. It is gonna update all of the packages one by one, and we're gonna wait for it to be done. Wait for it to upgrade. Once it is done, we are gonna continue with the installation. Yeah, if you see, it is updating the git git libraries. It is also upgrading. I think I saw OpenSSH up here. Systemd, which is the bootloader. This doesn't have a bootloader because it is integrated in the Windows operating system. And we don't need to install the Linux drivers separately because Windows ports the Linux drivers through WSL. But if you are in a completely new Linux distribution, it requires properly configured Linux drivers, which is a pain in the ass compared to using it on Ubuntu through WSL. I have struggled a lot in real Linux distros like Pop! OS installing and Fedora installing Linux drivers and everything. It is pain. So it is so much easier through Ubuntu. Through WSL. I'm sorry, I'm keep repeating Ubuntu. But yeah, through WSL it is a lot easier for to install Linux drivers because your Windows drivers will be ported to the Linux distribution. Now we need to first install two things. Sudo I have to install Excel, which is a multi-threaded download manager for the terminal, a replacement of wget, where you'll see what wget does in a minute. But now we can continue with our installation of Cuda. So we need to have a tool. We need to check whether we have something called build essentials. So I'm going to check for build essentials. Build essentials. I think I got the spelling wrong. Let's check. Essentials. Okay. Go. Okay. Right. Let's see. Did I get wrong? Build essential. Right. It's not essentials. It's essential. Right. So it's gonna install the build essentials build essential packages, which we are gonna need to build the run file. So yeah, we can try and enter. It will install the build essential packages. After that, we're just gonna copy this. So the difference between wget and Excel is wget is a single threaded downloader which is gonna take quite a while. Not quite a while. If your internet is quite fast, you'll download it relatively fast. But Excel downloads it in parallel, which will make the job so much easier for us. Like see, Excel is downloading the file, I think, in 4 portions, and it's gonna take around 10-11 minutes to download the whole thing. So let's wait for it to download. So now that it's finished downloading, and yeah, 4 gig took me 10 minutes. I have slow internet, and now we can run the build essential. We can run the next command, which is sudo sh Cuda 12.2 12.0 535 whatever. Let's run this command. And it's gonna take a while. If you do it, we can see that Nvidia is it's gonna take some time. packing a lot of stuff. You can see a lot of memory usage, some power usage went up, but it's gonna take a minute. Give it a minute. Pop-up is gonna do. Hold on. Some packing a lot of stuff. Yeah, right. So first of all, we have to accept the terms and conditions, accept to the terms and conditions. As you can see, we are downloading a very old Nvidia software, Cuda version. Then we are gonna install Cuda toolkit 2.0. So basically, if you wanna do an advanced install and select or not select anything from here, you can go for that. But we're just gonna install the default of everything. Install, and then it's gonna do its thing and install the Cuda toolkit, which will help us run softwares like Pytorch. We're gonna go to Pytorch's website. Pytorch's website. Torch. Then, if you just we can actually go there. Torch install. Start locally. After coming here, we can see the stable and the nightly build, and for Linux, we can use Conda or Anaconda, which is a software used for environments, building environments in Python. You can put precise versions of softwares, precise versions of libraries that you want in an environment so that they don't conflict with the other versions. Like I said, as you can see, the stable and the nightly builds, both of them only go up to Cuda 12.4. Okay, there is a support for ROCm 6.1, which is the if I'm not wrong, AMD's version of parallel computing, but Cuda does the best. Cuda is currently actually the best right now. So as we installed 12.2, we're gonna do 12.1, Cuda 12.1 support, but we can also get 12.4. You can install 12.4 locally, or even 12.6. 12.4 will work with 12.6. Cuda is backwards compatible, but if you install Cuda 12.2 and try to run Pytorch 12.4, it might cause some problems. I've never tried that myself, but it might cause some problems. So we can install 12.1 or 11.8. We can install 12.1, and let's try this. So as you can see, our Cuda is installed. Cuda toolkit 12.2 is installed. Drivers not selected. As I said previously, we don't want drivers installed. Now we need to get our directory into the path of our system. If we see here in VCC version, which will tell us whether Cuda is installed or not. As you can see, command VCC is not recognized, but we just installed Cuda. So what's wrong? We don't have the binaries in our path yet. So we need to add these two libraries, this directory and this directory in our path. Okay, how do we do that? We need to edit our bash rc file. Ubuntu uses bash shell by default. If you are using the ZHS shell, you need to edit the zsh rc file. So let's go sudo env, which is my preferred text editor for editing on the terminal. I can't get out of Vim, so I don't use Vim dot bash rc, and we will find the bash rc file, which is basically the configuration of the bash shell. I think we should have opened it in another terminal. Let's get out of here and open it in another terminal. We need to select the same version of Ubuntu and then run sudo nano. If you don't run sudo, it will not let you edit the bash rc file. Dot bash rc. The dot is important because bash rc is a dot file, which is a config file. It will ask for your sudo password, and then you are in. We'll go to end and add some new paths here. So hash this will give you, this will comment out the line, and you just type in path wrong. This is now we need to look for some paths on this. Copy them. Okay, I never set a path without ChatGPT or using an LLM. Let's run. Let's ask ChatGPT to do that for us. The toolkit installed. C will give us the commands we need to put in. Right, export. We need to copy this and then paste it in, and we need to save with Control O. Now, if we reopen our terminal, we will see and this is it works. Right, we can see the Cuda installed version, which is 12.2, and the build and compile. Now we can get to installing Pytorch, and we will come here, copy this, and then three not found. Okay, let's install three, so that is Python 3. We'll install the pip. Pip is the package manager for Python. If you are using Python in Windows, pip is automatically installed, but in WSL2 pip is not installed. I use Anaconda for my use case in default WSL terminal. Yeah, let's try it again. See, Ubuntu is not letting us install the Python packages system-wide. Okay, because apt is also a package manager, so this might cause conflicts. So what we need to do to install Pytorch, as we already have Cuda, we need to install Anaconda. Anaconda will help us manage our environments. So let's install Anaconda in WSL distribution terminal. Anaconda 3. Let's go to this. Let's install Anaconda 64 base installer. Let's copy the link address, and like I said, we can use wget, but we can also, now let's use wget and see the difference. And as you can see, by With wget we're getting somewhere between 7 which is the same speed that we got with excel. So I don't think it makes a difference whether we use WSL or excel when we are downloading with internet speeds like mine. It's really slow. Now that Cuda is installed in and we have our system variables set and Anaconda is installing, we will wait for a minute, and when Anaconda is done installing, we will set up the environment in which we are going to install Pytorch so that it doesn't conflict with the default Python environment of our system. We can see there is a Python version already installed in our system, which is 3.2.3. Now, if we use Anaconda, we will be able to create virtual environments where we will be able to install, say, Python 3.8, and it will not conflict with the 3.12 of our global system. So we will install Pytorch inside the Conda environment, which is virtual environment that keeps everything separate from the global or any other environments in the system, and we can work inside the environment with different versions of different libraries, and we could have, for example, NumPy 1 installed universally and NumPy 2.0 installed in the environment, and those two won't conflict with each other. Those two won't programs that require NumPy files won't fight each other for the versions. This is extremely useful when configuring TensorFlow, because TensorFlow requires very specific versions of very specific software. And also one thing to note is the Cuda NN libraries. Pytorch doesn't need Cuda NN libraries separately because Pytorch comes packaged with the Cuda NN softwares and everything along with the download. So as Anaconda has downloaded, we need to run Anaconda. See, ls is the downloaded files. So let's run sh the Anaconda script. So you need to agree to this. Say yes, and then we need to specify the installation location for the Anaconda. I recommend you install the Anaconda on the default location so that you can properly set it up on the path and you can find it. But if you prefer any other location, you can specify the location there to install itself. It is unpacking and extracting. Yeah, see, we can see Python libraries unpack. It is preparing the base environment in which we are going to install Pytorch. We are going to do everything in the terminal today. Can also show you the process through a VS Code terminal or like that, something like that. We can undo this. So every time we open basically what this does is every time we open Ubuntu 22.04, see the base there, it just by default sets up the Anaconda base environment for us. We don't get into the global Python environment, we get into the base environment. This can be pretty resolved pretty easily. We can just run this, or we can just put this in the bash rc settings. Now that Anaconda is here, we should be just able to type Conda, which is the package manager for Anaconda, and we can see that command is not found. So we will go over here. As we can see, base is activated. Command Conda should work. We can see Conda is working. Now we are going to list the I'm going to list the environments that are running or active currently in Anaconda. So Conda env list, which is gonna list the environment. We can see the base environment and asterisk beside. That means we are currently in this environment, this in virtual environment. Now let's clear it, clear the terminal. Then let's get the Pytorch image. Now we can either we can do a conda install or a quick install. It doesn't matter. It's gonna install in the default library storage of the conda settings. We're gonna do a conda install of Cuda 12.1. Now let's run this command conda install Pytorch. If you are now, this will install the Pytorch version that is supported along with Nvidia drivers, Cuda or parallel compute, and Torch audio and Torch vision. So if you see the packages while it's installing, you can see Cuda runtime, which is used to communicate with the Cuda toolkit, and you can also see, if I'm not wrong, it also installs the Cuda NN libraries, Cuda libraries, and Cuda NN libraries 2. It's not listed here, but it should install the Cuda NN libraries along with it. It's gonna download everything, which is gonna take a while. I'm gonna just fast forward this part in my edit. There's no module named Torch, so Pytorch hasn't finished installing. Let's install it. Let's wait for it to install. I don't know how much more time it's gonna take, but yeah, we're gonna wait. If we see here, Pytorch has done installing because it has imported into the Python editor. You can also use VS Code, you can use NeoVim, Vim, PyCharm, any editor you like, any IDE you like, Visual Studio, anything. I'm just going to show you in the terminal that whether we get output from. Okay, let's use VS Code. So let's exit from here, and then let's go to code. It's going to open up VS Code, installing VS Code servers for 64. As it's a new distribution, it's going to install the VS Code server, and then yeah, boom, we are in VS Code and in WSL. This is my user folder, or not my home folder. This is my user folder and my current user. So I'm gonna do code directory. I'm gonna make a file. Okay, I want to create a file. Let's open the files. No worries, I'm going to give it an extension which will be a .py extension. This is going to be Python extension, and then we're going to install the Python extension in the remote VS Code. Let's wait for it to get installed. Installing. Let's finish downloading. Let's go to code.py, and we can see Python has been detected. Yeah, right. If you see, the global installation of Python is here. Also, the Anaconda's virtual environment installation of Python is here. If we from here we can choose from which interpreter of Python we want to run our code from. I'm going to show you how to create another Conda environment. Conda create. First, I have to give the name of the environment. Let's give it the name test and Python 3 prefix. Oh yeah, right. We need to go under create and test and true. It's gonna create an environment which is solving environment field. Right? Yeah, it built an environment which has Python 3, Python installed. It's gonna build the environment, and voila, we have our environment. If we see on the list, you can see the test environment is there, and we can also find it here, test environment. Okay, so we can go into the test environment and import torch. If you see, there is no torch installed in the test environment, so it says fail to find torch. But if we go into the base environment where we installed torch, if we run it, you will see it runs because the base environment has torch installed in it. So let's see if we have Cuda enabled in torch. So print torch dot version. So print this return whether torch has Cuda enabled or not. Cuda is forgot the command file. So it's gonna give me, yeah, Cuda dot is right. Now if we run this file, we can see the torch has no attribute version. This torch this partial inserted Cuda. Yes, let me import torch.cuda is available for Torch Sincerity. I think our installation of Torch went wrong, but we will continue this in the next video. The video after this will have the rest of the Torch installation and the troubleshooting that is required to get Torch to work with Cuda. For today, I want to sleep, guys. It's quite late. It's 1:45 a.m. So I'm gonna go to sleep. I'm gonna edit and upload the video. Thank you for watching. If you watched this far into my video, really appreciate that. And I hope you learned something today, something new. This stuff is really exciting to me, and I'd like to continue doing this every day, or I want to do this every day. I hope I will. And that's about it. Thank you guys for watching. Good night, y'all.